Hi viewers, welcome back again to our channel. So today I'm going to explain how to write a prime number to find the sum of all the prime numbers between 1 to 100. This was a request from the user called her name is Shivani Power. She has requested us to write a code in Scala to find the sum of all the prime numbers between 1 to 100. Sure, Shivani. So here we go. So let me first open any online compiler, Scala compiler JW. So again, this is my favorite online compiling tool. So here, let me just delete all the default syntaxes that were given. So to find sum of prime numbers between 1 to 100. So the algorithm how I designed is so we can we can define one loop to one nested loop actually. So outer loop will run from one from three to 100 actually. So why 3 to 100 is because 1 and 0 are not prime numbers, so we don't need to find them also, and 2 is again a prime number. So this is where prime numbers start in the row. So we don't need to write special code for finding whether 2 is prime number or not. So that's why I just started from 3 onwards. So initially what I'll do is like I'll define one variable is prime. So to check by default I'll give one value true. So this is a boolean variable. So next what I'll do I'll define one more variable called sum. So sum initially will be 2 because 2 is a prime number that starts with. So I'll just take sum as 2 initially, and then later whatever the numbers that I find on the way, so I'll just add them to this same variable sum. So what I'll do is I'll run one loop from 3 to 100, and another loop, nested loop. So that will run from 2 to, so this is like outer loop variable is I. So 2 to I by 2. So I by 2 plus 1 actually. So what it does is, so from 3 to 100 I will take values from 1 to 100, like 3 to 100. Inside this what I'll do is like I'll define one more variable called j. So j will run from 2 to I by 2 plus 1. So what will happen is, so any number to check whether it is a prime number or not, so what is the basic formula is it should be divided by um, 1 and itself only. No other number should divide it. So if any other number divides it, its remainder will be 0. So what I'll do is like I'll take each time the number I, variable I. I'll check whether any number that is coming inside the loop, second loop, j, if it is dividing it successfully or not. So for that, what we can do, we can just use percentile variable. If it is equal to 0, then we can say that some number between 2 to I plus 1 by 2 will divide this particular I number, so that we can say that it is not a prime number. So why I have taken 2 to I by 2 is, suppose for example take a number 24. 24 will be divided by uh, 2, 3, 4, 8 and 12. So no other number that is greater than 12 will not divide 24. If you see 13 till 23, no other number will divide. So the same formula will be applicable for all other non-prime numbers. So the maximum number that can divide a particular number is I by 2 only. So this is why I have taken I by 2 here, I by 2. So that's how I'll define two inner loop, one nested loop, which is containing one inner loop as well. So inside this, I'll check if it is a prime number or not. If it is divided by some other number, I'll just say that is prime is false, which means that I am saying that this particular number is not a prime number. So outside what I'll do, I'll just check. I'll write one if condition. So if it is prime number means by default I have assigned is prime as true. So if any other number divides it, this is prime variable will become false here. So when it comes here, so this if condition will not be executed. So if there is any other number that is not dividing this particular I number, so this if condition inside if condition will not be executed, so that is prime will contain the same value true only. Then what I will do, I'll just add it to sum plus I. Sorry, sum plus I. I'll add here. Finally, what I'll do, I just print the same variable sum. This is how we can write. This is just a basic algorithm for that. So actual code implementation I'll do it now. So initially I'll define one variable called is prime true, where sum equal to. And another thing I just want to tell, in Scala we have two kinds of variables, one is val and one is var. So val is something that is similar to Java constants, final variables. So if we define any variable with val keyword, it cannot be changed in some other at some other point of time in our code. If we define it with the keyword var, we can change it anywhere in our code. So now let me define loop, outside loop for I 3 to 100, inside loop for j 2 to I plus I by 2 plus 1. So if I percentile, sorry, j double equals to 0, then what I'm doing is prime equal false. So inside this outer loop and outside of this for loop, outside of this inside loop, inside outer loop, what I'll do, I'll just check whether is prime double equals to true. If it equals to true, I'll just add the variable I to existing sum 2. Finally, I'll divide sum of, sorry, I'll print sum of all prime numbers between 1 to 100 is sum. Let me execute it. Oh, sorry, somewhere I have missed. So one thing I have missed here is we need to change this is prime to true again, because here we are changing after that whenever this loop starts, so is prime should be having the value true, then only it will execute properly. So this is how we can do it. So sum of all prime numbers between 1 to 100 is 1060. So let me just quickly explain one more time. So what I have done is I have taken two variables, is prime and one is sum. Is prime is to check whether a particular number is a prime number or not. Sum is to store sum of all the prime numbers. So I have defined a nested loop. So outer variable will run from 3 to 100, because sum I have already taken as 2. By default 2 is already added to sum, and 3 to 100 I'll run one loop. So in between 3 to 100, whichever the number is prime number, that I will add it to existing sum, some variable that contains 2. So inside loop runs from 2 to I by 2 plus 1. So that I have explained why I by 2 plus 1 only. So inside this loop I have defined one if condition. So this is what this if condition does is, so any number 3 in between 3 to 100 is divided is divisible by any number from I to 2 to I by 2 plus 1. So if that is successfully dividing means some other number is dividing it, so that we can confirm that it's not a prime number. That's why I have changed is prime flag to false. So outside this loop, what I'm doing is I'm just checking whether is prime is checked or not. So if is prime is not changing its value, by whatever the default value I have assigned previously true, that contains the true value on it, then I'm adding it to some variable. And finally I'm assigning back the value true to the flag is prime. So this is how we can define we can write one code to find sum of numbers, sum of all the prime numbers between 1 to 100 in Scala.